Recall my definition for the hyperbolic sine function. Likewise, I can think of this output as just y. Now, I would like to take a brief moment and generate out of thin air the output of the inverse hyperbolic sine function. Now, to get the output of the inverse hyperbolic sine function, I'll do a little bit of algebra. We've learned how to do that in 9th grade algebra. But notice how, since I defined the output of the hyperbolic sine of x in terms of my natural exponential function, then with the process you and I are going to go through right now, I should naturally find out in the end that the output of the inverse hyperbolic sine function should involve natural logarithms. So let's dive in. How do we find an inverse function? Well, we first interchange variables. And here's where all the work is. I now solve for y in terms of x. Might as well panic, get rid of fractions. Next, let's realize I failed to get rid of all the fractions because that could be interpreted as 1 over e to the y. So I'll multiply both sides by e to the y. Notice that this looks very quadratic. So let me write it as such. Now to solve this quadratic equation, I'll identify the variables e to the y and use my quadratic formula. That is to say, my negative b plus or minus my b squared. Sorry, I misspoke, didn't I? My negative b plus or minus the square root of my b squared minus my 4ac all over 2a. Allow me to clean up a little bit. Now, I think that should be the output of my inverse hyperbolic sine of x, but it can't be. It can't be. I can't have two possible outputs. That means the output of, that means the inverse hyperbolic sine function is not a function. It fails the vertical line test. So I need to make a decision of which component of the square root I'm going to choose, positive or negative. Now, to make my decision, I want you to go back very briefly to the graph of the hyperbolic sine function. There's what it looks like in the right-hand plane. Now, the graph of this equation can be generated by merely reflecting that image through the line y equals x. Now, as x increases upbound, so do the y values in this graph, just not as fast. But notice as if x increases upbound, this input is getting closer and closer to 0, which means it's going to negative infinity. It's not increasing that bound. So I guess I'm not going to choose that component of the square root, but this one instead. So we have just found that the output of the inverse hyperbolic sine function is described as such. I'll leave it for you. To derive this one, it's the same thing. I just get a sign change in the second term in the radicand's position. Now for this one, I'll rename this. I can't speak, sorry. I will re-identify those. I will next interchange variables. And solve for y. Here too, I'll get rid of fractions. Here too, I'll recognize that I failed to get rid of fractions completely. So I will multiply both sides by e to the y. Bringing all the terms involving the variable y to one side. Bringing all the other terms not involving the variable y to the right-hand side. Factoring out e to the y. I meant e to the 2y, not single y. I'll divide both sides by that binomial. I will take the natural log of both sides. And I will now divide both sides by 2 to come up with the output of the inverse hyperbolic tangent of x. I'll leave the remaining 3 for you, but these are certainly the most important ones.